Hey guys, Nick here. I'm coming at you from a beautiful villa in Kefalonia, Greece. So I'm kind of experimenting here to see if this works out, but I wanted to capture a screencast on setting up a local devnet. So now that we know how to sign transactions to transfer ETH, we are naturally going to want to do more interesting things with the chain, such as calling smart contracts. What makes Ethereum so powerful is the idea of smart contracts. As a Web3 developer, a lot of our time is spent understanding how different smart contracts work within the context of a given project. I like to think of smart contracts as an API interface that is on-chain and available to any developer to integrate with. This exposes a super powerful set of tools for us. So some popular examples of this are implementations such as basic ERC20 tokens, such as USDC or RPL. But there are many more complex projects such as Uniswap to be able to swap in and out of different tokens, or Rocket Pool, which is a layer for us to be able to provide liquid staking tokens and stake on the Ethereum network. So now we wouldn't just start calling into smart contracts on the Ethereum main network, or Mainnet as we call it. We want to first develop and iterate on our code in a more isolated and forgiving environment. Typically, the workflow looks like what you would expect in most software development projects. That is, we have a local development environment, a testing environment, and our production environment. In the blockchain space, these environments look a little bit different than we would typically say as a web application. A local development environment in the blockchain space would need access to an actual blockchain in order to expose the Ethereum endpoints, which allow us to actually interact with the chain. These are basically a standard API for interacting with the network. But we would need access to that state of the network in order to actually test our programs. And then once we're satisfied with our software locally, we can then test on a test net. And test nets are publicly available blockchains that we can connect to and test our code. It better matches the mainnet environment. We would need test net tokens and things like that to be able to do that. So we're not going to go too deep into test nets in this video, but what we're going to do is, in this video, we're going to focus on setting up a local devnet. And this is basically going to give us God mode to our own blockchain, which is super awesome and powerful. So we can masquerade as different users with a ton of ETH. We can interact with different smart contracts in different ways that we may not be able to do on mainnet because we just simply don't have the assets to be able to do it. So there are a bunch of different open source projects that gives us these capabilities quite easily. In this video, I'm going to outline how to use a project called Anvil, which is a utility that is part of the Foundry project. There are other options such as Hardhat that can achieve similar results. The goal of this video is to fork mainnet locally and then try to post a transaction using a test account loaded up with some test ETH. In the next video, we're going to go ahead and call into some smart contracts to swap ETH to another token using Uniswap. So let's go ahead and dive in. Now, in order to get this running on your machine, I'm currently on a Mac, but you could do this on Windows. Well, I typically do it on Windows within WSL, so I am running a Linux environment on Windows as well. So this is typically, I think you want to run Linux here or your Mac OS. So I'm going to go ahead and let's go ahead and take a look at the project here. So here is the Foundry project, and the Foundry project doesn't just consist of Anvil, which is the local development environment that we're going to be using. It consists of 4 core projects. There's a testing framework called Forge, a tool called Cast, which allows us to interact with different smart contracts, Anvil, which is what we're going to be looking at, which is kind of just like Ganache and the Hardhat toolset, and Chisel, which is kind of a REPL environment for us to be able to kind of just interact with the network. So we're going to be taking a look at Anvil. Now, to install this, it's pretty straightforward. This site here, getfoundry.sh, gives you a little curl command that you can pass right to bash. Now, I find this interesting because this is very popular amongst a lot of projects now where we could just kind of pass a bash script right into your environment. I tend to be a little hesitant to just blindly do this. So if you wanted to just take a look at the script here, you can go to this URL and this will show you exactly what it's going to be doing. So if you want to just browse through this and make sure that it's okay and you feel comfortable actually executing on your system, you always want to be a little hesitant to just blindly run scripts on your machine that could do different things. So this looks good. You want to go ahead and just pass this command on your command line, and that will install Foundry. So if we go ahead and go back to our command line here, and let's go ahead and get into the command line. And now I've actually already done this, so I do have it installed already. So if I just type Anvil, and I'm trying to hold my mic and do this at the same time. Let's see if I can do this. I do have Anvil 0.2 installed. And now with this installed, it's super simple to be able to just go ahead and fork a blockchain. Now, you can use a public node to do this. I do have a node that we already have set up on our network, on our internal Long Island blockchain network that I typically fork from. So the idea here is that you're going to be forking from a actual mainnet node. So you're going to go ahead and grab all that state and be able to fork right from it. So you have all the information that the chain has at the time of forking. Now to do this, it's pretty simple. You're going to go ahead and type this Anvil command, and there's a couple of different parameters that you're going to give to it. So you're going to give it a -f and then a URL to a execution client that you have running. So in this case, I'm going to LIBC prod 2 and port 8545. And now the next piece is your derivation path for your wallets. So this is something that's definitely a different topic, but in hierarchical deterministic wallets, you can take a seed phrase and then derive various different addresses, public and private keys, from that single seed phrase. Now to do that, there's a path that you can go down. So Ethereum has a specific path, Bitcoin has a certain path, the Gnosis chain has a certain path, different chains have different paths. And then you can kind of segment these paths so you can assign different users to different indexes and things like that. I am using a path that matches what MetaMask is using. So this way we can use MetaMask to be able to interact or import these private keys and use them. So this is just the derivation path that I'm using for MetaMask. You can try different ones if you need to for different applications, but this is the one that we're going to be using in this video. Now you can also specify a chain ID. Now you typically want to do this so that you can signify that this is a test net. Of course, mainnet is chain ID number 1. So this chain ID I'm making here is 31337. And that's pretty much it. Now once we have this in place, let's go ahead and run this. And then boom, now we have locally a testnet running. Super simple, using Anvil. So now we have these 10 test accounts. Each one of these test accounts are loaded up with 10,000 ETH. And we have the public keys right here, and we have the private keys. Now you can go ahead and take these private keys and load them right into your wallets. So you can put that right into MetaMask, right in your browser, and you'll be able to use these against this network. So you can see that this is the actual seed phrase that we use. This is the derivation path. You can see the endpoint that we connected to, the block number that we forked from, and the chain ID that we currently assigned. There's also a base fee or gas limit. And now, most importantly, it's actually sitting here on our local host listening on this port, which means now we have a local Ethereum node that we can connect to either from clients such as MetaMask or from software. And we're going to go ahead and try to connect to this bad boy right from our VM environments. So I actually have the code already written out here. And instead of going and clacking through the code here, I'm just going to go ahead and step through how this actually works. Vim actually has a really simple to use set of objects that we can go ahead and just use. So within the chains package here, we can use the Foundry object, and the Foundry object gives us access to our local local Anvil environment. So all we have to do is, using this create test client method here, this function, we can go ahead and instantiate a new client. And this new client is going to have all of the information to be able to connect to our local our local devnet. So you can see here there's an object that we need to pass into to this function, and we can go ahead and give it our chain, which the chain in this case is going to be Foundry, which contains all the information we need to connect to our local devnet. The mode is going to be Anvil, because we are using Anvil, and we're using an HTTP transport to be able to connect to it. So these defaults are all just kind of same defaults for us to be able to do default stuff. And what we want to do here is, this is quite interesting. We want to extend the public actions and the wallet actions. So remember, in previous videos, we talked about the public actions, which are essentially read-only actions against the chain. So things like get block number and maybe, get certain attributes about the chain. Nothing that has to do with signed transactions, which would change the state. That's what's in the wallet actions. So wallet actions is going to give us all the different actions to be able to sign transactions and basically call into contracts to change them. So with this in place, our client now, this client variable, is chock full of the functionality we need to be able to interact with our local devnet. So you can see here that we did something super simple, and we're just going to keep it pretty simple in this video. Don't want to make these too long. We went ahead and we just used the client to get the current block number, and then we log out the block number. Now what we're expecting here is, because we forked on this block number, I'm pretty sure we're going to just get this block number out when we run this program. So let's go ahead and give this a shot. Now we'll go ahead and run this, and then boom. On the console we see 203, 8269, and I'm pretty sure that is, yep, there we go. It looks like it, 96, yep, that's exactly what we expect. Now, in order for us to progress the chain, what we can do is, we can actually, what we can do is we can mine blocks. Now I find this kind of interesting because we don't really mine anymore, but this must just be a legacy thing that we can do here. So in order for us to go ahead and progress the chain, we do need to mine. So we're going to go ahead, and in this case, we're saying we don't really need to use this mine variable. We can actually take this out. And we're just going to await on client.mine, and we want to go ahead and mine one block. So if we go ahead and do that, and then we output the block number, we should go ahead and get a block number that's one higher than the one that we just saw. So let's go ahead and do that. And boom, there we go. So now we are progressing the chain on our local devnet. And let's go ahead into Anvil and let's take a look at what's going on here. You'll see that you'll get logs out here of exactly what RPC endpoints we're hitting for this particular on this particular node. So you can see we called ETH block number. We went and called Anvil_mine, which is a specific endpoint for us in a local devnet environment for us to progress the chain. And then we went and called block number again. So there we go. We have a local devnet, and we're able to interact with it, and now we can start to do more interesting things. So in the next video, we're going to go ahead and try to interact with some smart contracts, and we'll try to play God mode a little bit with some of our test accounts. And we may even try to, maybe not in the next video, but in subsequent videos, try to masquerade as other users so that we can start to say, hey, I want to play as this user that has a ton of this type of asset, and we want to try to swap into another asset. So really interesting things we can do to start to test out and just really play around and learn more about the environment that is the Ethereum blockchain space. All right, guys, I hope this was useful. I'm going to go ahead and take a dip into this pool right now. And if you like this type of content, please like and subscribe. I might try to get more while I'm out here, but I may just enjoy the nice environment a little bit here, my local environment. All right, talk to you later. Bye.